The three sp2 hybrids lie in a single plane with 120-degree angles between them, and the unhybridized p orbital is perpendicular to that sp2 plane. Think of an sp2 carbon like a person standing on a flat floor with three arms stretched out evenly, so each arm is the same distance from the others. Those three arms are the sp2 orbitals lying flat in the same plane and pointing away from each other at about 120 degrees, making a flat triangular arrangement. The leftover p orbital is like a flagpole sticking straight up from the floor at a right angle to those arms, sitting above and below the plane. When atoms bond, the flat sp2 orbitals form sigma bonds in that plane, and the upright p orbital can overlap side to side with another p to form a pi bond, which needs the perpendicular orientation. Picture the plane as a tabletop and the p orbital as a pencil standing on it to make the orientation clear. Students often imagine all orbitals pointing toward electrons instead of thinking about the directional shapes. So remember, orbitals are regions in space with specific directions and angles. Draw the plane and pencil to visualize this. Another common mistake is picturing equal bond types when one is sigma and one is pi. Say out loud that the in-plane sp2 bonds are sigma and the perpendicular p gives the pi overlap, so you keep the distinction. A third confusion is mixing up angles. Repeat that. The in-plane angles are 120 degrees and the perpendicular p is at 90 degrees to the plane to lock in the numbers. For more videos and resources on sp2 geometry and related topics, check out www.gumballdegree.com.